So the purpose of this video is to go through a graph of a trig function that has all the elements, the amplitude, the period, a horizontal shift, and a vertical shift. The main thing when you're doing this is just to keep your thoughts straight and keep yourself organized. So as I look at this here, the amplitude of this particular graph is a -2. The period of the graph is going to be 2 pi over 1/2, which is the same thing as 2 pi times 2 over 1. So this thing has a period of 4 pi. The start and end points, I can set up my inequality here to figure out the start and end points. And it might be a good idea here at this point, as you're watching this, maybe just pause the video and see if you can solve this algebraically yourself. Make sure you understand how it works. I'm going to multiply everything by 2. So that gives me a 4 pi there, and then I'm going to subtract a pi over 3. So now I got to take 4 pi minus pi over 3. So that's 12 pi over 3 minus 1 pi over 3. So that gives me 11 pi over 3. So there's the start and end point. This thing also has a vertical shift of -4, which we'll talk about. Alright, so when I go to graph this thing, I know it's going to be down -4. So I'm going to start with that. 1, 2, 3, 4. So my graph is going to be fluctuating above and below this line right here at -4. And how far is it going to go above and below? Well, that's where the amplitude comes in. So the amplitude's the absolute value of -2. So it's going to be going up 2 units, which is here, at -2. And it's going to be going down 2 units, which is at -6. And so I draw these lines in here just to kind of help me out so I know where the graph is going to be. Let's go ahead and label the x-axis here. The starting point is going to be at -pi over 3. So we'll put that here, and then 11 pi over 3. It's not going to be drawn perfectly to scale, but it will be close. 11 pi over 3 will be there. You got to have some sort of a number sense as to what pi over 3 and what 11 pi over 3 is. 11 pi over 3 is going to be 11 of these distances from 0 to pi over 3. It's going to be 11 of those put together. So you can see it's not going to be drawn perfectly to scale, but I think you'll get the idea. The midpoint now. So here's another thing that you can do. Maybe stop the tape and see if you can fill in these midpoints here on your own, and then start the tape again and check your work. So I'm going to take 11 pi over 3 plus a -pi over 3. So that's 10 pi over 3, and then I'm going to take half of it. So that's going to be 10 pi over 6. I reduce that to 5 pi over 3. If you're having a hard time with the midpoints, I have another videotape that will show you how to do these points. This ends up being 2 pi over 3, and over here is 8 pi over 3. How do I get 8 pi over 3? Well, if I take 11 plus 5, that's 16 pi over 3. Take half of it, that's 16 pi over 6, and then divide it by 2, that's 8 pi over 3. Alright, so these are going to be the critical points of the graph. It's a cosine graph with a negative value for the amplitude. So because it's a cosine graph, it's going to start here, then move up to here, and down. Now you can see it's not perfectly drawn to scale, and that's okay. It's not the end of the world. And if I wanted to keep this thing going, let's say it said graph 2 cycles, well, I would just keep these points going here. I'm running out of space, but look for the pattern. So 2, 5, 8, 11. That's going to be 14, 17, and then 20. Right? You can see the pattern. 2 pi over 3, then 5 pi over 3, 8 pi over 3. So the pattern will always be there, and you can just keep that pattern going. I'm not going to be able to fit the whole second cycle in here, but you get the idea of how that works. And so this would be the end product of your graph. That's how it works.